Okay, guys, so what we're going to be looking at today is this thing called the Pythagorean Theorem. And what the Pythagorean Theorem is used for is it's used to solve right triangles. And so a right triangle is a triangle that has a measurement that's 90 degrees. In math, what we do is we represent that by putting a little box in the corner for the angles that have a measure of 90 degrees. And you're going to go into more depth about this on the looking at triangles and stuff more specifically next year in geometry. But what I'm going to do is I'm going to show you how to do the algebra part of the Pythagorean theorem. And so what it is as you guys know, for a triangle there's always three sides to a triangle, and in a right triangle we have a special side, which is the long side or the diagonal, the slanted side, which we call the hypotenuse. So if you look at my drawing right here, our hypotenuse would be C. So I'm going to just write that there for you to know. Okay, so in a right triangle, we always have this slanted long side. We call that the hypotenuse, and that's our C in this problem. And then the other two sides are just A and B, and they're just regular two sides. There's nothing really special about them. And yeah, so there's nothing really special about them. It's just that they're two sides, the other two sides that make up the three sides of a triangle. So, what the Pythagorean theorem is you add, you have one side, which is A, and you square it. You have the other side, which is B, and you square that, and you add them together, and that's supposed to equal what the hypotenuse, C squared, is. Okay, so this is the general formula of what we're going to be working on today. And so, again, the Pythagorean theorem can only be used for right triangles, and because I'm running out of space, I'm just going to put a triangle there. So right triangles, that's what it's special for. Okay, so what we're doing here is I'm asking you in this first part to find the missing length correct to the nearest hundredth. So you're not going to be giving me numbers and radicals anymore for this section, because I want you to give me them in decimals. So you might actually need a calculator for this. Okay, so let's just set this up. So in number one, I give you A. Don't give you B, but I give you C. So you're trying to tell me what B is. So all you do is you plug these numbers into the Pythagorean theorem. So A is, remember, it's A squared plus B squared equals C squared. You're trying to solve for B this time. So A is 10, but we have to square it. We don't know what B is, so we just leave it as B squared. C squared is 26. C squared is 26 squared. And so all you do now is you start working this out. And so we have 10 squared is going to end up being, like you guys know, 100. We have plus b squared, and then 26 squared is going to give us, I'm going to help you out, 676. Okay, just like what we did yesterday for the solving portion, let's get b by itself. So we're going to start subtracting 100, subtract 100, and so we get b squared equals 576. And so what will be cool for today is that you can use your calculator, because like I said, you gotta give me answers to the nearest hundredth, and so you don't have to worry about radicals, so you can actually use your calculator to help you find this out. Okay, so b is going to equal, sorry, just shifted this whole thing over here. B is going to equal whatever the square root of 576 is, so punch that into your calculator, and you should end up getting 24. And remember what we did yesterday, we said that when we have to draw in our own radical to solve, it's going to end up being positive or negative 24. But because we're dealing with a triangle this time, remember, a triangle or any kind of special figure like that, it can't have a negative length. So because we're dealing with a triangle, the only answer we are going to take is just positive 24. We don't need the negative because we can't have a negative side. So answer for this is going to be 24. B is 24. Okay? Alright, so let's go ahead, let's try another one. So number 2, I have A is 8, B is 5, C, I don't know, so we're going to find out what C is. So here's what we do. We're going to just plug it into the Pythagorean theorem. So 8 squared plus 5 squared equals C squared. We have 64 plus 25 equals c squared. And then what do we end up getting? So we add up the 64 and the 25 and we get 89 equals c squared. And then we got to solve this out. So let's solve this out here. So we get square root that side, square root that side. So c equals, go punch the square root of 89 into your calculator, round it to the nearest hundredth. Okay. And then if you do it correctly, you should end up with 9.43. C is 9.43. Okay? All right. Let's work on this number 3. Okay? So we have here A is 8, B is 8, and then C we don't know, so we're going to go 8 squared plus 8 squared equals C squared. We know that 8 squared is 64, so we have 64 plus 64 equals C squared. What is 64 plus 64? We got 128 is C squared. Square root both sides so we can get rid of that exponent on that C. So square root, and so when you punch the square root of 128 into your calculator and round it to the nearest hundredth, answer should be 11.31. And remember, under normal circumstances, it would be plus or minus 11.31, but because we're dealing with a triangle, our triangle cannot have a negative side, so we're just going to take the positive 11.31. Okay? All right, let's finish out this lesson today on the Pythagorean Theorem with another set of directions. And so let me condense this down so you can read all the directions here. Oops, where are we here? Okay, sorry, a little tiny there, but I want to make sure we can fit it in there. So, state whether or not should be or not, the given 3 numbers. Let me put a little t there so that makes sense with your notes here. State whether or not the 3 given numbers represent lengths of the sides of a right triangle. So how can we do this? I give you 3 sides of a triangle pretty much, and what I'm asking you to do is to verify that these sides could be for a right triangle. So remember, the first thing I told you about the Pythagorean theorem is that it was special to only right triangles. So all we're going to do is you're going to take these 3 sides and plug them into the Pythagorean theorem, okay? And it should work out on and equal each other. So I know they don't label what A, B, C is, but just take them in order. So the first one's A, second one's B, third one's C. Just always treat it that way, okay? So let's plug in those numbers into the Pythagorean theorem and see if we end up getting something that will work out. Okay. So we have 20 squared plus 21 squared equals 29 squared. So 20 squared we know is 400. 21 squared, maybe you may not know, but it's 441. 29 squared is 841. And then let's add up the left side. 400 plus 441 is 841. And we had 841 already on the right side. So yes, this stuff, it worked out. So yes, this is a right triangle. Okay. And so what would you show me for this for work? Everything that I just did. Plug it in, work it out, either put a check mark or a not equal sign, and then tell me yes or no, this is a right triangle or it's not a right triangle. Okay? Let's try it with number 5 and C. So again, just take them in order, even though it's not labeled. The first one's A, next one's B, this one's C. So we got 15 squared plus 20 squared equals 25 squared. And then work this out. So 15 squared is 225. 20 squared is 400. And then 25 squared is 625. If we look at the left side, 225 plus 400 is 625. And these two are definitely equal. So yes, again, this is a right triangle. Okay. And that's it. So hopefully the Pythagorean theorem, it's good. Memorize it. It's one of those equations you really, really need to, you should memorize because it will help you out in life as a math student. A squared plus B squared equals C squared. And so that's it. And don't forget to take the quiz.